this particular part. And this part will have some profile turning on the OD. It'll have a little bit of grooving work, and it'll have some threading. So we'll write a program for that. So when I go into the program mode, it brings me to the main menu of programming. I can give it a program name for file storage, either numeric, or randomly there's a little blue question mark here. You press that Alt key, and it brings you to a manual keypad, where you can plug in your own. I'll just give it today's date, 12/06/12, and set that in. You can write event comments into your program, or you can just start by pressing go to the beginning, and now you're in the main menu of programming. So a little brief description of the event type. Position event is just a rapid move to locate the tool to some location. A drill event would be if you had a drill chuck in the tool post and you were hex drilling group post. Or function would be doing any IG kind of cutouts. And then a turn event could be pretty much a single line routine to do any turning on Z, facing. An arc event would be doing any segment of a radius. But what you'll find out here that there'll be 3 or 4 event types that you commonly use on this track lathe. And one of them is the cycle. So the cycle event will allow you to create a profile of this workpiece, then tell it the stock size, and it will create the tool path. So we're going to start with the cycle event. So the cycle event is going to ask me where I want to begin. Well, on my workpiece here, the center and the end of my workpiece is going to be my starting point, my absolute zero. So I want to begin at X and Z absolute zero. And so now, because there's going to be multiple cuts in this routine, it asks, how deep do I want each cut? So depending upon the material and the tool, I'm going to enter a value, in this case here, 50 thousandths. So every cut will be 50 thousandths deep. When I'm making these 50 thousandths cuts, it's asking, do I want to remove the material on the x-axis? So that would be 50 thousandths this way. That would be a lot of cuts. Versus 50 thousandths this way. That would be much more efficient. So that's going to be along with the z-axis. So when you're programming and you're asked for entering RPM, it gives you 2 options. The RPM, which would be a constant, you'd enter that value and select incremental setting. And that's the one we're going to stick with. Surface feed is a little bit more dangerous to work with because it's going to constantly change the RPM and the feed. So I think we want to really, for the novice, stay away from it. So we're going to give it an RPM of maybe 1,000. It's asking what kind of feed rate, and it will ask for either in inches per minute or thousandths per revolution. Pretty typically with a soft material, 5 or 6 inches per minute is a good starting point. And for both the RPM and the feed rate, you have that override key that before you go and cut, if it's going too fast or too slow, you can select one and bump it up or down. So now you have to identify what tool number we have here. And so it would be good if you'd get a picture of the tool board here. You because you have your tool setups. Okay. We really want to stay focused with the tools and always identifying them as the particular tool number, which will describe what tool type. So in this case here, tool number 1 represents this type of tool. It's a right-handed turning and facing tool. It's a tool that can machine this part. Drop that in and lock that down. And then if you'd like a finish cut at the end, after all these roughing passes, you can put in that value, maybe 5 thousandths. And when you do the finish cut, you can speed up or slow down both the feed rate and the RPM. So we'll go a little bit quicker on the RPM, and maybe a little bit slower on the feed rate to get a little bit better finish. And then we're going to instruct it to use a same tool number 1 when we do that finish. So that's just the parameters of the cycle. It's now going to ask us to create each point that will represent this part. So we're starting here, we're going to come out to here, and we're going to start to turn along that length. So I'm going to do a cycle turn event, and that's going to take me to this diameter, which is 500 thousandths. So that's going to be your X plus 500, and the Z staying at absolute 0. But then maybe in that corner, we want a little, break that edge and put a little chamfer of 50 thousandths and press absolute set to access that chamfer function. We're now going to go from here down to here by doing another turn event. The X, the diameter is staying at 500 thousandths, but the Z is going negative 750 thousandths. And there's no chamfer at that point there. So while you're in the program mode, you can always press the look key and it will start to draw the part. And it will show you each move as you make it. So we're creating that finished part right now. And I want to select another cycle turn event. And I want to go from here to this point here, which is 868 thousandths, so 0.868 on X. And the Z dimension is going out to 2.657. That's a negative 2.657, and that's an absolute dimension. There's no chamfer at that point either. So if you press the look key, now you can see that taper has been programmed. We're going to select another cycle turn event, because we're now going to come out to this diameter here, which in this case the workpiece is 1 inch 250, Kevin? Is that correct? Yeah, 1 inch 500.
Yeah, 1 500.
1.5. So the workpiece is 1.5. So we want to come out to that diameter. And leave the Z dimension at negative 2.657. Now at that point there, we want to put a small chamfer on the workpiece, so I'm going to put in an 0.50 thousandths chamfer by entering that value and pressing absolute set. Okay. So I'm going to do one more cut along this diameter here by doing a cycle turn. Keep the X at 1.5 diameter, but have the Z travel down to maybe negative 3 inches. So, to continue on here, with the cycle event, this cycle event is a series of cycle turn events that have created a finished part boundary. That's a boundary that the tool cannot void when it's making all of its roughing passes to remove that material. And those are accomplished by selecting either cycle turn for line events or cycle arc for round surfaces. Once we've completed the finished part boundary, we now have to identify the material. And actually, this dimension, the stock, is actually larger than what it's drawn out here. So I have to instruct it that there's stock all the way along that line that represents this 1.5 inch diameter. And at that point there, you jump over and start programming cycle position events. And I'm going to tell it at X, we have material out to 1 inch 500 diameter, all the way back to the end of the workpiece, which is absolute 0. If you press the look key here, you'll see you have a dotted line all the way out at 1 inch 500 diameter. And then you have to end the cycle when you begin. And so the easiest way of doing that is ending the cycle. And the control will tell you the cycle has not been closed, but if you press the yes key, it will add a cycle position event and close it. So now you can see you have another position event, and it's got a dotted line going back to where you began. So cycle turn events to create a finished part boundary, cycle position events to identify the raw material. So for the time being, we're going to exit the program mode, pressing mode, going back to the main menu, and now we're going to go in and go to our setup mode and start touching off and identifying our tools. So in this case here, setup, it's asking me for tool setup. So in the setup mode, you have your tool setups. You can view the tool path, and then your reference for setting your home. So tool setup, tool number 1. And in the case here, for the way things have been set up, tool number 1 has already been identified. So instead of setting a new, we're going to edit the existing tool that's in current memory. These things are going to be pre-saved. So it knows that tool number 1 is a right-handed turning and facing tool. So it's instructing us to move to a known X, somewhere in the workpiece that we can measure and enter that value. So I can now turn the spindle on, and I can use the hand wheels. So again, I'm going to come in here and just take a little material, remove a little material. Cut the spindle off. So I can now measure that down. That's 1 inch 390 thousandths. So it's asking me to move to a known X, input it, and set it. So X is at 1.39 set. It's now asking me to move and identify the face of the part. Move to a known Z. Well, I know the end of the part is 0, so spindle on. Again, that's the end of the part. And that's establishing the end of the workpiece as move to a known Z, input it, that's 0. The tool nose radius is the radius tip on that tool that's already been entered in. I don't want to change that. And then you have modifiers for both your diameter and your longitudinal. So if you're doing critical measurements, in precise machining here, you would probably want to enter a modifier on X of positive some value, 5, 10 thousandths. And that will allow you to creep up to the dimensions, measure the workpiece, and then adjust your modifier based upon the amount of tool pressure or tool weight. Alright, so we'll data forward through those fields. We're not entering any offsets. Or better yet, maybe I will put land. I'll put in a 10 thousandths positive modifier on X. We'll cut the part. We should be over, and then we'll adjust it. Z's not that critical, so we'll just focus on the X. If you have another tool to put in, we put it in now and touch it off. At this point here, there's no other tools in this program, so I'm going to select return. And after the tool setup, you can view the tool path. Okay, so now if you view that screen, I'm going to zoom in on that just a bit. So it will show every pass that that tool will make. So it starts at the largest diameter and removes the material, getting down to the small diameter, never voiding the finished part dimension. So rough profile and then finished profile. So after viewing that, you gave a good idea and that you're in control and things look pretty well. So mode, again, takes me back to the main menu so I can get prepared to run the machine. So I went into digital readout mode and just quickly moved the tool back away from the workpiece. That way there, when we start up, I have some time to observe the tool. So we're going to go into the run mode. So these things have happened in that natural progression. We used it as a manual machine in digital readout mode. We went in and we wrote a program. That's the only program in memory. Luckily, or hopefully, we've skipped the edit mode because we've entered it correctly. We've touched off our tools and viewed the tool path in the setup mode, and now run. So the start key says ready to begin, press go when ready. Well, when I press go, this is going to be in CNC motion and it's going to go in rapid feed how I program. And so just as a safety feature, we input this tracking function, and you always want to select the tracking function, and that's going to allow you to move the hand wheels at the speed you want, and it will cut the part with you turning the hand wheel. So it says put in tool 1, make sure that's locked, turn your spindle on, and press go for CNC run of tracking. So when I press go, it activates the spindle, and as I turn the hand wheel, it's going to show the tool approaching the workpiece. So I can use the Z-axis for coarse, the X-axis for fine. If I turn it the wrong way, it just follows the program backwards. So I have to turn it towards the workpiece. And at this point here, you can observe the digital readout. See that you're a few hundred thousandths away, and it'll start to cut the workpiece. So this is going to be a safety feature that if you get too close to that chuck, spinning chuck, stop turning the hand wheel. Once it's reached its final depth, which was that 2.5-inch dimension, it backs away, and you'll see it'll come back to the beginning, enter in, and take out the next step. So coarse on the Z-axis, fine. So at this point here, I'm pretty confident that things look good. I'd like to go into an automatic mode. And in automatic mode, the door needs to be closed, I hit the stop key, it'll ask if I want to leave tracking and go to automatic or CNC run. So when I press CNC run, it says ready to go, press go. So when I press go, it's going to pick up the feeds and speeds that we programmed. Maybe at this time I may want to take my feed override and slow that down a bit before I press go. If you're uncomfortable what it's doing, stop. Quick, easy way to stop it. Hit the emergency stop. That will stop the spindle as well. Or continue. So I'm going to take the feed rate and I'm going to bump that up because we're at 4.8 inches a minute. And I believe we programmed 6. While it's cutting the parts, you can take your screen, go back and forth if you wanted to look at the program, view what's going on with the program, shows the dimensional location, your feed and speed percentages. We'll go back to viewing the cutting path. So there's a lot of roughing cuts to remove this material. Remember, we put that modifier in on the tool so that we'll be able to adjust the position of the tool. So after we've completed this and measured it, when we do that tool modification, there'll be a simple way of starting on the finished cut only so we don't have to remove all these cuts. Doing the rough finish cut, it's taking all those high points out of the workpiece. At any point, if I was uncomfortable with the tool location, I could hit the stop key, go back to tracking, and take over by hand, and it will follow the finished part at the speed I turn the handle. And now it'll go back home. So at this point here, I'm going to hit the stop key, go to CNC run, and it will run automatic. So one interesting to observe, we're getting a spindle override RPM, and that's because I've programmed a faster RPM than what's set up in the maximum spindle out here, so we'll go back and change that. So now we'll go back home. Shut the spindle off, runs complete. So there's your work piece.